Hey, I'm back, and we're talking about writing linear inequalities from a graph.
Yeah,
We did a similar exercise writing linear equations from a graph. These are linear inequalities, and you're really going to think it's interesting the difference. So here's our first example. We've got a graph here, and we're going to write a linear equation from it. You can see over here, this is an old example.
This is an old example. We've already done this, right? What we've done is we've taken this graph of this line and we've made an equation in slope-intercept form. And since it's slope, we had to find the slope. And since it's intercept, we found the intercept, and then we just typed it into Schoology. So if we look here, right, the first thing that we did was we identified the y-intercept. So where is this line crossing the y-axis? Well, if I start at the top of the y-axis and I go all the way down until I see the line, then I know, okay, the y value here is 4. So we found our y-intercept first.
Now we also need to find our slope. So I'm going to start at this axis, at this intercept, because I know that it hits on a solid corner, and I'm going to find another corner. Not at a corner, that looks pretty good. Not at a corner, that one looks pretty. Okay, so I can use this point here. So in order to get from this point to this point, I go a rise of 1, and I go a run of 2. And then I ask myself, is this a positive or negative slope? This is a negative slope. It's heading down from left to right, so this is a negative slope.
Good. And now all we did was we closed it out by putting in m and b. So if we were to type this in, and I'm just going to write it for now, we would put our slope, which is negative 1, and then x, remember we put in the numerator, slash, the denominator is 2, and plus 4. And then we close it out by putting enter and getting it correct.
So if we're typing it in, y equals negative 1x, you can also just say negative x, divided by 2 plus 4. So that's how we're going to go ahead and close this out. Our next problem, you'll notice, is very similar. The only real difference that we're seeing in this next problem is there's a little bit of shading going on, and that represents the inequality. So the only change we'll really see here is the sign that we use instead of an equal sign. So rather than y equals mx plus b, this sign here is going to change, and we'll explain how that works.
Yep. And it's just like we did in lesson 32, where instead we had the equal sign, we had the inequality sign, right? So that's really the only difference. We've got y and then some inequality sign, and everything else is the same. So here we're given a line, just like we were in the old example, and the first thing that we have to do is figure out what the y-intercept is. So the process remains the same. You look at the y-axis, and you go down until you see the line where it crosses. So here it crosses again at 4. So we know that our y-intercept is 4.
Similarly, we can find our slope by beginning at 4 and moving down and over till we hit a corner again. And again, we go 1, a rise of 1, a run of 2, and this, tracing from left to right, is a negative slope. As we begin to put the equation together, we can say that y equals negative 1/2 x plus 4. And at this point, we have an equation, and we can change this sign to represent the inequality. So there are 4 types of inequalities. We have greater than, less than, greater than or equal to, less than or equal to. So we're going to try to figure out what this looks like. Is the shading, which means the included points, are those greater than the line or less than the line? Well, because it's below the line, we know that it's less than. So that immediately tells us we're going to either use this less than symbol or this less than or equal to symbol. Then we look at the line, and we see if the line is included or it's not. A solid line means it is included, just like when we were graphing inequalities before. We had open holes and closed holes. For these graphs, we have solid lines, and we have dotted lines. Solid line means it's included. We're going to use this symbol. So we just replace the equal sign here with this symbol. Y is less than or equal to negative 1/2 x plus 4, and we're ready to close it out.
And I'll close it out for us. So we come down here. type in y less than equal to negative, and now you can either put 1x, since it's a fraction you can write the 1, or you can just put x divided by 2 for the slope, and then our y-intercept was 4.
So if we go back, I want you to look at these two problems. This was writing an equation from a graph. This was writing an equation from a graph of an inequality. Can you see how similar they are? It's the exact same graph, except the first one is an equation, and the second one is an inequality. That should help you make the connection between the new thing that we're doing from the old.
Good, so here we have this our second example. We're only doing 3 today, so we'll keep it nice and short. The first thing we're going to do is we're going to find b, then we're going to find what the slope is, and then we're going to determine whether it's greater than or less than, and then we're going to determine whether or not it's an equal to or not, right? So let's go ahead and figure out what the b value is here, and sadly it is already given to us, but if we had to find it again, we know that we're going to look to see where this red dotted line crosses the y, and the y value that it's crossing out is 4. So we've got the b value.
Then we jump into finding the slope. We begin at this point. We go to the next point that we can find that hits, not a line, just barely missed it, not there, boom, there it is. So to get from this point to that point, 1, 2, 3, 4, 5, 6, 7. So we have a rise of 7. 1, 2, and a run of 2. Is this a positive or a negative slope? It is a positive slope. Now we can begin to decide if it's above the line or below the line. The easiest way to tell is to begin here at the 4 and to move to the shaded area. I moved up to the shaded area. It is above the line. So I know if it's above the line that these values are greater than the equation. So I'm going to use a greater than sign.
Good. And now we just have to determine whether or not it's equal to or not, and we just look at whether or not the line is dotted or dashed, dashed or solid. Well, it's clearly dashed, and that's similar if we had an open dot, so we know that it's not equal to. So we have y, and this sign right here, greater than, because the y values are shaded are greater. The slope is 7 over 2. And the y-intercept is 4.
So as we begin to close this out, you come down here and enter y is greater than 7x over 2 plus 4. And again, just to touch base for a moment on step 4, when we said not, what we're saying is it's not either of these signs that include equal to. Not means we get rid of these two types of signs. So we'll go through the same process here. We find our b, then we find our m. Then we decide, this I guess would be step 3, if it's one of these signs or one of these signs. So step 1, step 2, find b, find m, decide which sign it is, above, below, above and equal, below and equal. And then step 4 is we decide if we get to keep these signs or not. So I'll go ahead and find b. Track it all the way down to -3. Next I find my slope. Looking for another corner. Boom, there it is. Up 1. There's my rise. Over 2. And moving from left to right, it goes up the line, so this is a positive slope. The next thing I want to look at is, based on this line and the shading, which of the signs do I use?
Yeah, and an easy way to do that is just to use that y-intercept point that we have. And if you can think about the y-axis as a number line, these y values that are up here are y values that are greater than our y-intercept, right? And these y values below it are y values that are less. So now we have to determine where is the line shaded. Well, it's shaded down here where all the y values are less than our y-intercept. So we know that we're dealing with a less than. So we can cross out these greater than signs. So now we have to determine for our fourth step, is it just greater than is it just less than, or is it less than and equal to? And remember, we determine that based on whether or not it's a dotted line, which would be the equivalent to an open dot, or if it's a solid line, which would be a closed dot. And if we look at the line, clearly it's dotted, so we know that the points on the line are not included. So we know this is the sign that we are using.
We go ahead and close it out by creating our equation. Y is less than 1x over 2 minus 3. And when I type it in, I'm leaving the 1 off just because I like it that way. I believe the Schoology coding will let you put the 1 in if you want to, but we'll leave it off. So x over 2 minus 3, and we've closed it out. What I really like about this lesson is how similar it is to what we've done in the past. If you'll fill out the guided notes on this one and you'll do the problem set, you'll be really, really successful.
Good luck.